Hi friends, welcome to our new series of sensors, transducers and signal conditioning paper. So here we'll be discussing some typical topics that are available in a paper of sensors, transducers and signal conditioners. So to start with, let's start with the definition of sensors or transducers and then what is the role of transducers in a generalized measurement system. So we have seen sensors, transducers, and signal conditioning in the generalized measurement system. But now let's go deep into this and try to understand what are the definitions of sensors, transducers, and what is their role for different applications, right? So let's understand the definition per se. If you see the definition, a transducer is a device that converts energy from one form to another, one physical form to another form. So pressure to electricity, electricity to pressure, mechanical to chemical, chemical to mechanical. So one form of energy into another form of energy. Whereas a sensor is a transducer in itself that receives and responds to a signal or stimulus from a physical system. It just receives some response from the physical system. That's why we normally call it as a sensor. Let's get into slightly deeper into this. So basically transducer converts one form of energy into another form of energy. If you see the slight difference between sensor and transducer, if you see the definition itself, a sensor is a device which detects one form of energy and converts the data to electrical energy. So lower values, lower magnitudes, lower amplitudes of electrical signals, electrical output, if you are getting from a device, and that we normally call it as to be specific, we call it as a sensor. Whereas a transducer is a device which converts one form of energy into another, as we have seen earlier. So sensors are in fact a type of transducers. So if the signals available are of very low electrical energy, we normally call them as sensor. That's as good as that. Then if you see the function wise, a sensor is a device which detects a physical quantity and produces an electrical signal based on the strength of the measured quantity. We normally call it as a measurand. Quantity that's being measured is termed as measurand. So that is exactly what is the function of a sensor. Whereas a transducer is a device which converts one form of energy into another form. Basically, the definition and function are more correlated in that way. Then the sensing element is the sensing element itself, whereas a transducer is sensing element plus some associated circuitry. There could be some other transducing part of it after sensing the thing, because the output of the sensor is always a very, very low output electrical signal. And that has to be suitably converted to a stage where it can be detected by the signal conditioning system. This we will understand when we come to the role of the transducer. Then when it comes to the feedback, both can be used and cannot by itself give feedback to the system as a sensor. But whereas a transducer can be more conveniently used as a feedback element in any control system. So a physical change is normally sensing the physical change. It's giving a very light signal, and where you have another transduction element to convert it into electrical output. So these are the typical examples. We have a typical transducer may look like this. A typical sensor may look like this. So again, a transducer, usually it converts a signal from one form into another form that we have seen. Whereas here, it can be a module, or it can be a device, or it can be a subsystem, for the purpose of which is basically to detect events or changes in its environment and send the information to other electronics, frequently a computer processor, or it can be a little, because the output of the sensor is always a low electrical signal. That's exactly is the definition by difference of transducer and sensor. If you take a typical example to understand the signal, we have an audio signal which is coming, a transducer which is converting into a electronic signal, and then you have electronic processors, signal conditioning we normally call it, and then it is transmitter. transmitting to a longer distance. We normally call it as a telemetry in the form of electromagnetic waves. Right now, these electromagnetic waves are received by a receiver, which is nothing but an electronic circuitry, a capacitor ganch. Then this converts into electronic signal. This electronic signal is converted back by a given transducer from electronic to audio signal, and that signal we normally listen it. So if you see, the audio signal is getting converted into an electrical signal, and it's being transmitted to far off distances, again received by another receiver, and then electrical signal is again the transducer here. This transducer is converting audio signal into electronic signal, whereas this transducer is converting electronic signal into audio signal. So that's the exact role of the sensors and transducers in a typical application. Then again, you have a physical quantity which is being converted by a transducer into an analog signal, which is being read here. This can be another example, right? This is another example which we have seen. A microphone, typical microphone is an input device, whatever thing, then it is given to an amplifier, and it's then a loudspeaker is an output device, because this amplifies the signal, low magnitude signal that is getting, then it is given to the loudspeaker, and here it is basically the amplified signal, the same form. These are the typical examples. We have a piezoelectric sensors, pressure to electrical signal. When we apply a compressive force here, we get the electric charge that we can easily read it here. So this is a air quality measurement sensor. Then we have temperature sensors, RTD, resistance temperature detector. Then we have a thermocouple. Then we have a thermistor and semiconductor. All these are the transducers which give the electrical output. So for all practical purposes, we can call them as sensors also, right? So that is the basic difference of this. So this is a typical linear variable differential transformer, LVDT we normally call it, where the displacement is being converted into electrical signal, where we take the output. We have a primary winding and secondary winding here. The difference, when we excite the primary winding, the output that we are getting at the secondary winding is proportional to the displacement of the core. Okay, this is a typical principle of a transducer where we are getting. And then if you see the typical measurements, all these parameters, displacement, linear velocity, angular velocity, acceleration, force, pressure, temperature, heat flux, humidity, flow rate, light intensity, chemical characteristics or chemical composition, any of these parameters, physical parameters or chemical parameters that we are measuring, we normally call them as measurands. Now these are subjected to sensor or transducer. It can be a gauge, or it can be a cell, or it can be a pickup coil, or it can be a transmitter. Whereas these are, convert these physical changes to electrical pulses. Okay, so then this signal is given to a signal conditioning system, where the signal conditioning system, you can have amplification, attenuation of the signal, filtering the signal through high pass, band pass, or low pass, or band pass, and then differentiation, integration of the signal, linearization of the signal, converting a resistance into voltage signal, converting a current signal into voltage signal, and any of these things can happen in signal conditioning system. And ultimately this signal is given to a display or a processor or a recorder or a data logger, whatever may be the thing. So if this entire thing is taken as an instrument system, and the role of the transducer or a sensor is effectively to convert the physical changes into electrical pulses, which can be conveniently and comfortably conditioned by an electronic signal conditioning system, in order to give a signal in such a way that it can be comfortably and conveniently displayed or recorded or processed by an external element. So this is the role of sensors and transducers in a typical generalized measurement system. So that's what we have learned. We have learned the definitions of sensors and transducers and the role of transducers in a generalized measurement system. Thank you very much. Keep watching for more related topics in sensors, transducers, and signal conditioning.